Hello and welcome. In this video I'm going to complete a series of tasks for MPLS on OcNOS devices. The tasks includes this. It says that provide MPLS l3vpn service to customer Globetrotter. As you can see, Globetrotter has two different branches on two parts of the city, let's say, and our service provider is going to provide the connection between these two on control plane level and data plane level, which means that we need to make sure that we have the prefixes transferred to the other side, and also data can traverse the network to the other side. The second says use BGP as a PEC routing protocol. This part, of course, is done in a previous task. I'm just showing you what the configuration is going to look like, and in the end it says that use the same autonomous system 65001 on all CE devices for BGP. I'm going to change this a little bit. Let's say that because this is a private number, I'm just going to say that let's go with 650 for Globetrotter on this side, and let's say 651 on the other side, and later I'm going to change it to both 650 just to see the result of the configuration. So let's see what is going to happen. So first of all, let's take a look at our topology and the previous configuration so that we know where we are going to go. So in this topology, as you can see, there is our service provider, OENet Solutions. Our service provider has multiple routers. Two of them are PEs, as a matter of fact. But in a big service provider, we might have multiple PEs in different places. Now, what I'm trying to say is I'm going to assume that I don't have two PEs, I have multiple PEs. And what I'm going to do is to reduce the number of BGP neighborships, because I want to have full mesh, but not in a way that every router can have a BGP neighborship with other routers. So what I'm trying to do is to create a route reflector. Now, the task explicitly said that I should not have any address family other than VPN v4. So this means that IPv4 address family is not going to be configured inside my service provider network. So what I'm trying to do is to say I'm just going to have VPN v4 connections, and this is going to be my route reflector. Router 5 and router 1 are going to be my route reflector clients. So one thing that is important, why do I need to have VPN v4 address family when you have VRFs configured for BGP specifically? When you have VRFs, VPN v4 is going to convey the prefixes for each one of those VRFs to the other side, which means that router 3 is just going to be used for a prefix transport to the other side. And also, of course, reducing the number of sessions was the premier purpose for this. The other thing is, in my case, of course, router 3 might be on the path of data, but I can just configure this in a way that this could be an offline route reflector. And later, of course, we are going to do that in a separate video, but for now, this is going to be okay. Now, the order of operations are going to be important. So far, I have done this piece of configuration. Every other piece of configuration is going to be done on all PEs. So on router 1, what I need to do is going to be this. First of all, I need to enable MPLS. So MPLS, or multi-protocol label switching, is going to be enabled under the interfaces. I have deliberately changed the color of the links and the routers involved in MPLS configuration so that you can easily understand which interfaces should be MPLS enabled. So you can see that I have Ethernet 1 and Ethernet 2 from router 1 configured with MPLS. This part should be done on all routers. It doesn't matter whether this is a provider edge router or a provider core router. So I'm going to configure this on all routers. So let's say that this is going to be on all routers inside our network. The next part, of course, is going to be done again on all routers, and that is LDP. LDP, or Label Distribution Protocol, is going to be the standard label distribution protocol that we are going to use. With this, we are going to create the labels, and with this, we are going to say that loopback interface is going to be the actual LDP router ID. In this case, we are going to call it transport address. So LDP is going to be again configured on all routers. Okay, so this part is done. The rest are going to be on router 1 and router 5. So let's just change the color so that you can understand which one is going to be like that. On router 1, I'm going to configure VRFs, and specifically I'm just creating VRF for this network with this customer, Globetrotter. I'm going to just call it GT. This VRF is going to be assigned to the interface, specifically this interface, Ethernet 6. The customer, of course, doesn't have to do any changing configuration. Customer doesn't know anything about VRF. Customer doesn't know anything about my network. From customer's point of view, my network is a transparent transport used just to connect to the other branches. After creating this VRF and assigning that to the interfaces, I'm going to create VPN v4 address family, and of course I have done it before, but I'm going to create it in case I don't have it, and also address family IPv4 unicast for VRF GT. So these are going to be the important steps that we are going to take one by one, and we are going to test the configuration one by one so that we can know that there is no problem in our configuration. Okay, let's start this with the first part, enabling MPLS on all routers. So you can see that interfaces are here. The command is super easy. It's just label switching. You go under the physical interfaces and you say label switching. No configuration on loopback interface, of course. So on router 1, I have Ethernet 1 and 2. So I just go to here and I say interface ETH1. I say label switching. And on interface ETH2, I'm going to say the same thing, label switching, not on loopback interface. So this part is going to be done on this. Next is to enable LDP on the interfaces. And again, this is going to be on the physical interface. So I'm going to say again, interface ETH1. I'm going to say LDP enable. So enable LDP for IPv4. Of course, IPv4 is the only option, but we are going to have it for both of them. So Ethernet 2 is going to have the same thing. Next is I need to configure LDP process. Now on OcNOS, LDP process is called a router process. So what I'm going to do is to say router LDP, and under that I'm going to say transport address. That's for IPv4. That is going to be 1111, and I'm using loopback interface IP address for that. So I need to say commit the configuration. Okay, so let's show this. Do show run. I don't have to, of course, have do here. So just say show run interface loopback. Just says that I have this IP address configured, and that interface ETH1 says that label switching is enabled and enable LDP for IPv4 is there. So what I'm trying to do is to just copy this to other interfaces and other routers, and then I'm going to show some of the verification commands. For now, let's say end, and I'm just going to say show and LDP, and there are two commands under LDP which is going to be interesting for me. One of them is going to be adjacency, the other one is going to be session. Both of them should be successful, and also of course interface. For now, let's say that I'm going to say show LDP interface. It says that Ethernet 1 and 2 are enabled for that. Show LDP adjacency. For now there is no adjacency, and of course yes, there is an adjacency because I might have configured router 2 with some LDP, but I'm going to just do it for now. And finally, I'm going to say show LDP session. That says the session between router 1 and 2 and 3, of course, are operational, working, and just fine. So I have configured this before, and right now you can see the configuration. Let's go to router 2. I'm just going to show the configuration. So if I say show run interface, for example, ETH1, you can see that label switching is on there. ETH2, and of course, and ETH3 is configured with this. And also, if I just say show run router LDP, you can see that transport IPv4 address is configured for these routers. So I have done it before. This is for the sake of just trying to reduce the size of the video. Okay, just to make sure, again, I'm going to show you the commands. Show LDP interface is very important. Show LDP adjacency is going to be the next one, and also show LDP session. These are the verification commands. And when you have made sure that this is working on all of the routers inside my service provider, what I'm going to do is to say show MPLS forwarding table. Hit enter. This is going to show you a list of labels, and this is going to happen only if everything is working just fine so far. So you can see that for each one of the prefixes in my network, I have a label created. And this label, of course, is going to be different on different routers. Let's just check one of them. Router 1 is on one side, router 5 is on the other side. Let's say that router 1 wants to reach to router 5 using MPLS. So for that, it says, what is the label created for 5555? So I go to router 1 and I check it. Router 1 says for 5555, the label which is created is 26,263, and this is created by router 3. So the next hop is going to be router 3. So let's say that I'm going to say show MPLS forwarding, and for this specific one, 5555/32, it says that this is what we have. And do I have any detail for that? No. Okay, so I'm going to use this. So this means that this is going to go to router 3 using Ethernet 2. So here it goes to router 3. On router 3, I'm going to check this, and it says that 5555, I'm going to have this label 3, which is implicit null label, which means that the outer label is going to be removed and then be sent to the neighbor. So this means that my next hop is going to be 5555, which is the end of my network, and I'm going to kind of finish. So because I am next to the last hop, I'm just removing this outer label, and there are multiple reasons for that. One of the reasons is with this behavior, which we call it penultimate hop popping, we are just reducing the load on the PEs. PEs are going to have a lot of different features enabled on them, and when you can just reduce its load a little bit, that's going to be a big help for the router. Okay, great. This part is done. Let's do something else. I'm going to go to router 1 and try to ping router 5 using MPLS. On router 1, if I just go and say ping 5555 and I source it from, let's say, 1111, this is going to use a normal IP packet forwarding to the destination. It works. That is based on ISIS, and that's okay. No problem with that. But now I'm going to say ping MPLS. Ping MPLS is going to be a little different. This time I'm going to try to use MPLS. And if I check here, you can see that there are different types of MPLS here. What we have done so far was using LDP. So I'm going to use LDP, and after that I'm going to say 5555/32, and then I can say, let's say, source is going to be 1111 and hit enter. You see that the ping is successful and it goes to the destination 100% rate. So MPLS network is just fine end to end. Everything is working great. And now I'm going to do something else. The next thing is to go to router 1 and router 5. We have done everything in core and PEs, but PEs need extra configuration. On PEs, I'm going to create VRFs. A VRF is a virtual routing and forwarding instance. A VRF means that I'm trying to isolate the traffic and control plane, of course, for a specific let's say, interfaces. In my case, I have multiple interfaces or maybe sub-interfaces. Here, I am interested in this one, Ethernet 06. This should belong to a VRF, which I call it Globetrotter or GT. This VRF, of course, has some prefixes. I mean, the customer doesn't know anything about VRF, but anyway, this branch wants to get to the other branch, and each one of them have some prefixes. Now, when I receive these prefixes into my network, what I'm going to do is to say, okay, there is a very big bucket here, and I put all the prefixes inside this bucket from Alex, ABC, Kenzo, Globetrotter. All of them go inside this, let's say like this. For example, these are prefixes. How am I supposed to know that this prefix is for Globetrotter, this prefix is for Kenzo? There is the value which we call it RD. RD, or route distinguisher, is a tag. Is an 8-byte tag that you just add to each prefix. To say that, for example, this one is for Globetrotter because I have just added the tag for that. This one is for Globetrotter. This one is for Globetrotter. This one is for, let's say, Kenzo. This one is for Kenzo. Even if those prefixes are the same, based on RD, I can tell that this one is for Globetrotter, and I'm just going to pick this. That one is for Kenzo. I'm not going to touch that. So RD is an 8-byte value, and you can write it in multiple ways. One way is something like an IP address, for example, 1111, and then the second part could be a number, for example, 1. The one that I am trying to use is numbers on both sides of the colon. So what I'm going to do is to say this is for Globetrotter, and I'm going to say this is, let's say, 6 because this is connected to Ethernet 6. This is just a number that I'm adding. Doesn't mean anything other than that. So my RD is going to be 66. Okay, RD is used to identify these. What about route target? What is route target? A route target is a policy. A route target is a community value, an extended community value. A route target is going to decide where we are sending this prefix and where we are receiving prefixes from. Let me show you something. Let's say that Globetrotter is going to be considered as number 1. The other branch, Globetrotter, is going to be considered as number 2. Okay, each one of them have some prefixes. I want to say, okay, because I want to reach to Globetrotter branch 2, I need the prefixes from branch 2. So I am going to import all the prefixes from branch 2. I'm going to say import 2. And because I want branch 2 to reach to me, I am exporting my prefixes to them. So I'm going to say export is going to be 1. On the other side, this one is going to say the exact same thing. It's going to say I am importing 1 because I need the prefixes from the other side so that I can reach to that. And I'm going to send my prefixes to there, so I'm exporting 2. So you see, based on this, I can tell what you are receiving from me, what I am receiving from you. Maybe I'm not sending some prefixes to you, so you cannot really reach to those prefixes. Okay? This is this. Let's say that service provider has another customer here, or maybe something like internet connectivity, or let's say a server which everybody should have access to. There are multiple scenarios that you can just talk about that. In this case, let's say, for example, I have internet configuration here, and I'm going to internet connection here, which I'm going to provide for each one of my customers. And let's say that this INET is called 3. So this means that now, because Globetrotter wants to get to INET, it needs to import 3 as well. The other side, of course, as well. So it needs to import 3 as well. So think of route target as some policies to import and export. And when you want to configure it, you need to configure communities, extended communities on the neighbor connectivity. With this said, you should know that on OcNOS, these extended communities are by default on. You don't have to do anything special about that. This is going to be apply it for you, and the only thing that you need to do is to enable that IPv4 neighbor. That's it. By activating the neighbor, and everything is going to be done for you. Okay, so let's do the configuration right now. I guess everything is set, and now we need to go back to our console here. So on router 1, I'm going to create the VRF. So let's say that I'm going to configuration mode, and I say IP VRF, and it is called GT, whatever name that you are going to have. So for this, I'm going to configure an RD of, let's say, 6. This number is not so important. For each customer, you can allocate one or more route distinguishers. There are multiple scenarios for that. Of course, I'm not going to speak about this, but you should know that a route distinguisher could be multiple for one customer. And I'm going to configure route target, and just to be simple, I'm just going to say 6 for this, and I'm going to say route target for both import and export is going to be the same thing, which means that for both sides I'm just assigning the same number. You can just assign multiple different numbers, you can assign the same numbers, doesn't matter. What I'm trying to do is to say, because I'm going to be super simple, I'm just using this. Okay, so route target is both like this, and other commands you can see that route target is used. We can have a router ID in this case, but I don't really care about that. And if I just come up in the list, nothing important. So I'm going to create this and say commit. Okay, so let's say do show run VRF GT, of course, and this is the configuration that I have. I'm going to copy this to the other side as well. So I just go to router 5 configuration mode, and I'm just copying here. That's for the sake of configuration. Okay, now which interfaces belong to this specific VRF? In my case, Ethernet 6. You might have a sub interface. I'm going to say do show, or just show is going to do, of course, show run interface ETH6. My ETH6 doesn't have any configuration. If you have an IP address, be careful about that. The reason that I'm doing this show run is because I want to see what I have under this. As soon as I apply the VRF to the interface, the IP address is going to be removed. And if you want to apply the same IP address, so this is going to be a good strategy. I'm going to say, I don't have it, but that's okay. I'm going to say Ethernet 6. IP VRF forwarding is going to be GT, and after that I'm going to have an IP address of 10.1.12.1/24. Then I'm going to say commit. Now if I say show run interface ETH6, you can see both of these commands here. They should be here. And of course no shot, in case it is shot, but I believe that mine is not. The same thing on the other side. Here we have 5.13 and Ethernet 6. So I'm going to go to router 5 and I'm going to say interface ETH6. In case show run interface ETH6. I don't have any configuration, but be careful about that. In case you have an IP address and you want to reapply it. So I'm going to say IP VRF forwarding is going to be GT. IP address is going to be 10.1.10.1.10.5/24. No shut in case it is shut down. And I'm going to commit the configuration. Okay, let's go back to here. Before continuing, I want to show you something. On router 12, I have configured the IP address. So if I just go to router 12 and log in, of course, first of all, and I'm trying to say ping 10.1.12.1, the ping is successful. If I go to router 1 and say ping 10.1.12.12, the thing is not going to go through. Why? It says network is unreachable. The reason is this is under VRF. This is separate. whenever you do something, you are trying to do it on global VRF, which is going to be the actual instance that you're working on. But right now, we are trying to reach that using another instance. So for this, I need to say VRF GT in the end. And now you can see that everything is working. Also, if I say do show IP route, you can see that this is the default VRF, which is a global VRF. But in case you want to see the routes for your neighbor, for your customer, for this specific VRF, you have to say VRF GT in the end, and you can see that now this interface is under Globetrotter VRF. It is not under the global VRF here. Okay, so with this said, you should know that in case I want to create an adjacency for a routing protocol, I need to do it under this VRF, and that is exactly what I'm trying to do. Let me just take a look at the configuration of BGP here. So far, if I say show run router BGP, you can see that for now, what I have is a BGP configuration, no IPv4 address families here, just VPN v4 unicast address family, which is going to be okay for us. So I'm going to say router BGP 100. I'm going to create an IPv4 connectivity with router 12, which is going to be in 650, autonomous system 650. But this is under VRF, so I need to specify the VRF here. So I say VRF GT. Under this, I'm going to say neighbor 10, 1, 12, 12, which is in remote AES 650. It should be activated. And that's it. And I'm going to say commit here. Nothing more than that. On router 12, of course, I need to create this BGP process. So I'm going to say configure terminal, router BGP 650. I'm going to say let's say BGP router ID I can configure here as 12, 12, 12, 12. Doesn't matter, of course, but neighbor is going to be 10, 1, 12, 1. In remote AES 100. And I'm going to go to address family IPv4 unicast. I'm not creating a VRF here. That's a customer edge router. It doesn't have to have any VRF. So, but you can have it, but you don't really need it. I'm going to say this should be activated, and also I'm going to advertise 12, 12, 12, 12 slash 32. Then I'm going to say commit. Now it is time to configure the BGP process. In a previous video, I showed you that router 3 was a route reflector, a VPN v4 route reflector for router 6 and router 1. For now, this is not going to be necessary, so what I'm going to do is to configure router 1 and router 5 as BGP neighbors directly. Later, of course, we are going to use router 3 as VPN v4 route reflector in a separate video. So you have seen the configuration. Now I'm going to change the configuration a little bit. I have deleted router BGP on router 1 and router 5. Like I said, based on the requirements, I'm going to enable a VPN v4 only. I'm not going to enable IPv4 there. So on router 1, what I'm going to do is to go to configuration. I'm going to say router BGP 100. Let's say the BGP router ID is going to be 1111. Let's say my neighbor is going to be 5555, which is in remote AES 100. And this is going to use an update source of 1111. And now I'm going to go to address family VPN v4 unicast. And under this, I'm going to activate this neighbor. That's it. I can say send community both or extended. Of course, extended is necessary here because, like I said, route target is an extended community. But if I say this is going to say that we have already enabled them. You don't need to do this command, so that's okay. I'm going to say commit. And now I'm going to create an adjacency with Globetrotter as well. But let's go to router 5 and do the configuration back. So here, router BGP 100, BGP router ID is going to be 5555. My neighbor is going to be 1111, which is in remote AS of 100 with an update source of 5555. And I'm going to go to address family VPN v4 unicast, and under this neighbor is going to be activated. Okay, so, and also send community both, but like I said, this is by default their commit. Okay, let's verify. I'm going to say do show IP BGP VPN v4 all summary, and it says that I am in adjacency with router 5. And let's go for configuration of the adjacency with router 12. First, let's go to router 12. Router 12 has no understanding of VRF, so I'm going to say configuration, and I'm going to say router BGP is going to be in autonomous system 650 for now, of course. BGP router ID is going to be 12, 12, 12, 12. My neighbor is going to be 10, 1, 12, 1 in remote AS of 100. And under address family IPv4 unicast, for this is everything as normal configuration. That's going to be activated. And also under this address family, let's advertise 12, 12, 12, 12 / 32. So I'm going to commit this. Going back to router 1 is going to have the adjacency under a VRF. So I'm going to say exit this address family, the current address family. I'm going to have address family IPv4, not unicast this time, VRF GT, because this should go under the VRF. And the neighbor is 10, 1, 12, 12, which is in remote AS, of 650. I'm going to activate it. And I might want to advertise something, but let's say that I'm going to advertise the connected networks as well. So I'm going to say redistribute connected, and you would know that with this, I'm just redistributing Ethernet 6 because this is the only interface under VRF GT. So that's going to be advertised into connected network. This is not necessary, but I'm just going to do it. Okay, so I'm going to commit it. The same thing should happen on router 5. So I'm going to go to router 5, router BGP 100 process, and then I'm going to say address family IPv4 VRF is going to be globetrotter. Under that, I'm going to have a neighbor of 10, 5, 13, 13, which will be in remote AS of 651 for now, and then, or let's say 650, why 65, 61? We can just, let's do it, doesn't matter. And we can just change it at any time, no problem. And also I'm going to say redistribute connected networks as well. So I'm going to commit this. Let's go to router 13 and do the configuration of AS 651. EN configure terminal router BGP 651. BGP router ID is going to be 13, 13, 13, 13. Under address family, first of all, let's say that neighbor 10, 5, 13, 5 is in remote AS 100. Remote AS 100. Under address family IPv4 VRF GT, no VRF, because this is the customer doesn't have any understanding of VRF. I'm going to say this should be activated. And also I'm going to advertise 13, 13, 13, 13 to the other side. Of course, it should be /32. So let's just say no, this one. Okay, let's commit the configuration. Okay, so everything should be fine now. On router 1, for example, I'm going to say show IP, do show, of course, do show IP BGP VPN v4 summary. VPN all, I guess. No, not this one. What was the command? Because I used it before. Here, show IPBGP VPN v4 all summary. So now you can see that when I say all, it means all VRFs. This is the global VRF. VPN v4, of course, not global. This is the address family for my customer. You can see that I have sent one and received one. So if I just say do show BGP this, you can see the prefixes that I am receiving and sending. You can see that I have 13, 13, 13, 13 from the other side, from 651. This means that if I go to each one of these customer sites, for example 12, and say do show IPBGP, I should see the prefix from the other side. So when the configuration is done, now I'm going to test the connectivity and then recap what we have done. So on router 12, I'm going to say show IPBGP. It shows that everything is received in here. Then I'm going to say show IP route, and it says that all of those routes are installed. And if I try to ping 13, 13, 13, 13, and I'm going to source it from 12, 12, 12, 12, the ping goes through without any problem. What I did was I configured l3vpn. I have a customer with the name of Globetrotter, and Globetrotter has two sites connected to my service provider. I configured MPLS on all of these red links, and on the loopback, of course, I didn't configure anything because loopback is not going to take the MPLS configuration, but loopback is going to be used as LDP transport address, so I'm going to use that. LDP was configured on all of these interfaces, and label switching, which is MPLS, was configured on all of these switches. I showed you MPLS forwarding table. I showed you the LDP sessions and LDP adjacencies, and after that I created a VPN v4 connection between these two using BGP. VPN v4 address family was used under BGP to configure that, because on one side we have BGP 650, on the other side we have 651. There was no problem sending the prefixes to the other side. But let's do something in the end. I'm going to configure both of these as 650 so that we have the prerequisites of the task met, because I'm going to add one line of command. It could be done on the web, on the sites, on the branches of the customer, or it can be done on PEs. So if I just go to, let's say, Globetrotter on router 13, what I'm going to do is to say en show run router BGP. What I'm going to do is to change this configuration a little bit. So I'm going to say no router BGP 651, and I'm going to commit this configuration, and then I'm going to say 650. So both sides are going to be 650, and I'm going to do this configuration. Let's go to router 5, which is adjacent with router 13. So I'm going to say show run router BGP here, and here I'm going to say configure terminal router BGP 100 under address family IPv4. I need to say no this neighbor, and I'm going to configure this as 650, and then I need to activate that. Then I'm going to commit the configuration. This means that if I go to router 13 and say do show IP BGP summary, now I should have the adjacency with this router 5. Right now it is working just fine. But the thing is, if I say do show IP BGP, I'm not gonna reach to the other side. The problem is the loop prevention stops me from receiving the prefixes with the same autonomous system number that I have. Now, like I said, there are two different solutions for that. I can configure allow ASN on here on the branches, or I can say AS override on the service provider, whichever you want to do. So let's just examine allow ASN on router 12 and 13, and then you can configure allow AS override on router 11, router 1 and 5, the same solution. So if I say show run router BGP, I'm going to go to configuration of my router BGP here under address family IPv4 unicast. What I'm going to do is to say this neighbor, and after that allow ASN. So I'm going to allow ASN, and after that number of occurrences of AS number. I'm going to say one repetition is going to be enough. But in case you are adding some extra, let's say prepending of your autonomous system number, you can just increase it to something like 3. So I'm going to say 3, and I'm going to do the same thing. So on the other side, so I just committed here. On router 13, I'm going to say address family IPv4 unicast, and for this neighbor, which is this one, I'm going to say allow ASN, and I'm going to say 3 for the occurrences. So let's commit the configuration, do clear IPBGP any out, and also inbound. Just let's do this on router 12 as well, and then I'm going to say do show IPBGP. Now you can see that now we are receiving the prefix, and if I try to ping 13, 13, 13, 13 with the source IP of 12, 12, 12, 12, the ping goes through. The other solution, like I said, is to have AS override. I'm not going to configure that because that's almost the same as this, and you can just do it for yourself, but you should do it on router 1 and router 5 for the neighbors that we have here. With this, this video is going to finish. I hope this has been informative for you, and see you in next videos.